My name is Nelson Venegas. I am from PhD student from Warsaw University of Applied Sciences. Today I'm going to talk a little bit about the detection of trends in observable floods in Poland. It was a work that we were working together, joined with Zbigniew Hindewicz, Jambro, and Mikołaj Piniewski. Well, my master and my bachelor's, I did a geography, and now I'm more related with hydrology and water management. And in the past, I was studying droughts, and now I'm moving to the floods. So I'm studying the extreme events in general. So this is the overview about the topic for today. First of all, is the introduction, the study area, the data and method that we use in this work, the results, and some specific examples of European scale floods, more focus on Baltic states, and at the end, the summary of the presentation. First of all, in the justification that why we decide to work on this a specific topic is because in Poland is recurrently affected by floods. We have in this case, I just wrote two specific examples. One in 1997 in the Odra River Basin, and in 2010 in the Vistula Basin, with consequences in economic aspects, infrastructure, and even human fatalities. Also, the floods are extreme events that they are a variable in time, and also for local conditions. And in Poland, they are they could be associated with different local conditions. For example, extreme precipitation, snow melt cover, and so on. Then the global scale and pan-European studies on flood detection, they didn't include Poland at all, or in sometimes they just include Poland, but a few number of time series. And also, for example, that they usually use data until 2010. So for that reason, we wanted to see what is the behavior until 2020, to see what is the real situation of the floods in Poland. Now we have here the study area. Basically, we use the whole country of Poland. We decided to divide into 12 major river basins that are those basins, and basically we decided to do this one to have a better comprehension of the floods, and also to distinguish what is the principal factors of the floods in Poland. Also, well, there is some examples of the precipitation and also the temperature. Here you can see the map of the temperature, and basically the annual average temperature in Poland is around 8 degrees. Obviously, we have increasing or decreasing spatial variability. For example, to the west, near to the border, we have higher temperatures, and in the south, near to Slovakia or in the Tatra Mountain, we have less temperature. And then for the annual total precipitation, in general, the behavior of the precipitation is in the middle, and in the central part of Poland, we have an annual precipitation of about around 500 and 700 millimeters per year. And in the south, near to the Tatra Mountain, we have the highest amount of precipitation that would be around even above 1,600 millimeters per year. And in this sector, near to Lithuania border, to the northeast, is the part that we have less precipitation also. And now, more in detail, the data that we used for this study was basically stream flow gauges around Poland. It was observed data. We extracted daily data from the Institute of Meteorology, Water Management, National Research Institute from Poland. We decided to have two different periods of this study. The first of all was from 1956 to 2019, to maximize the temporal coverage, because we will have a more time series and the result will be better, let's say. And then we have another subset to maximize like the spatial coverage, because we will have like a more gauges around pollen. Here, like the little like triangles are like the different data that we use. And in this, like a subset D are around like 150 gauges, and the first one around 60 gauges. It is important to say like the median of all the catchment that we decide to use is around like 550 square kilometers, and the range is between 6 and near to 7,000 square kilometers. As you can see, we have like a really big variability of gauges that we study, and for that reason we wanted to do it. The next one. Now I'm going to talk like a little bit about the methodology. First of all, it's important to say that we use two specific approaches. The first one was like the annual maximum flow, that basically is just like to extract the maximal value per year. So we will have just one value per year to do the analysis of the trend. We did it like in hydrological year, that from pollen is like from 1st of November to 30 October. Also we decide apply like the other approach that is called like a peaks over the threshold, and this basically is to detect how many peaks we have like above certain threshold. In this case, from our study, we decide to use like 3 different threshold, because in pollen we have like different behaviors of the discharge, or also like the stream flow data. So in some cases we have to apply like one threshold or another to have like a real good number of peaks. And also we decide to have like a criterion of 30 days of separation, because if we didn't apply like this criterion, we can have like too many peaks that are related just with one event. So for that reason, we apply 30 days to have like a separately flat events. And in that case, we will see what is like the frequency, if they are like increasing or decreasing. This is like the figure like of the methodology that we apply. As I told you before, we apply like the peaks of the threshold and also like the maximum value per year. And with that, we extracted like the flood time series. Then we wanted to make like the trend analysis with 3 indicators that they are like a magnitude, frequency, and timing. With those like indicators, we applied like the trend analysis methodology that we base on McKendall test and also like the same slope, but just for the magnitude and timing. And it is based like in this like formula. And for the frequency, that is like another kind of behavior, we apply like the chi-squared of parametric Poisson. And this is because like the frequency is like we are counting how many floods or how events we have or we had in the past. So this statistic is better to detect if they are like increasing or decreasing for the historical period. Also at the end, just to see what is like the behavior of the average timing from the floods in Poland, we apply like this statistics that is called like a mean day high flow. And basically we just transform like the regular time of floods into an angular value to see if the floods are like occurring like between January or April, like in August, and we will have like the direction of arrow, and we will see when is like the floods occur. And now I'm going to talk like more in detail about like the results that we had with this analysis. First of all, is based on the flood magnitude. In general, as here in the map, you will see like in the first row is like the annual maximum flow, and the second row is like the peaks of the threshold, and the changes are like in percentage per decade, and like the colors, they are meaning like in the orange or red colors is like I'm decreasing, so we had like a less magnitude of floods. And when they are like in blue colors, it means like it's like increasing of the number of the flood magnitude. In general, the pattern of pollen is like a decreasing, so like a less floods. Basically, it is focused more like in the northeast border near to Lithuania. Here, like we have even like a 15% negative of like increasing, decreasing flood magnitude, and it is like related with higher temperatures that we have like we are facing in this specific period. And also like we found like one specific increasing like a tendency, and it's like in the south, like it's related with the Tatra Mountains. And basically this behavior in the south are related with heavy and long precipitation around 3 or 5 days that we have like in this sector, and for that reason like the magnitude is like increasing. Also it's like our study is like kind of, they have like a similar pattern with previous studies that different people were working. So for example, this is like a study that Blatch et al. In 2019, they did an analysis of the flood trends over Europe. And this is like the changes in the magnitude as we did in our paper. And for example, they found like the same, like a pattern in the middle and the northeast of Poland with a decreasing of the magnitude from the floods. And like in the south, like with an increasing of the magnitude. Just we have like a difference that is like related to this part near to the Baltic Sea. And basically is like because we use like a different data, and also like the time period is like longer. And they have like this period until 2010, and after 2010 we have like a really difference between like the temperature. Let's say we have like an increase of temperature, and for that reason in this part now we didn't have like we don't have like such increased tendency. And also that is important to mention that even though we have like this kind of global studies, also it's important to have like a local scales, because for example in Poland we have like a different conditions and different behavior of the stream flow that it will make like a difference in the magnitude. So now it's like almost the same, but now with the frequency and the colors here they do well. Like the colors are like the same, like the colors like orange. They are like increasing in the decreasing in the frequency, and with the blue they are like increasing. In general, we didn't find like any evident or a strong behavior of the frequency in if they are like changing to be like a more frequent or not, because like the changes in the even we just had like 0.2 events changes per decade. So the value is like a really small, but in general, like the behavior is almost the same, like the same pattern that the magnitude. In the middle and the central north part of Poland, we have like a decreasing, and the increasing is like in the south, that is like related with the Tatra Mountains. And also like this is like a very important, like the overview of the decreasing trend is like a big, is because we have like a less severe freezing in Poland, and also because like the soil moisture is decreasing. So if the soil moisture is decreasing, when the precipitation amount is too high, like the soil moisture will be like equal, we will not have like a flood even in this part. And now is basically the same, that we compare like our result with this paper of Blatch et al. 2017, and they did like the same like flood timing average from Europe, and the arrows, like the position of the arrows, like means like where is like the average of the floods from Poland. And for example, in general in Poland, they have like in the central part of this sector, in the north, like between April and between February and April, and in the southern Poland, like in the Tatra Mountains, like the behavior is between May and July, and is like related with summer floods. So in this case, we have like a more precipitation, and for that reason, we have like a floods in this period, and or like results are like in general in the same pattern than this paper. And for example, in this, like in the Baltics states, like for example, Estonia, Latvia, and Estonia, they have like the behavior mostly between like April, February, and March. Now for the another like for the timing, but like the previous one was like related when was like occurring like the floods, like for example, in between October or September, between months. Now we have like a detection of if the floods are like occurring like earlier, let's say like 2 or 3 days earlier, or after. So like basically like the color represented like in red colors are like with earlier occurrences. Let's say like the red color, it means like the floods are like occurring 8 days earlier. And for example, in the blue colors, like it means like they are like occurring 8 days later. In general, we have like one specific behavior in the northwest of Poland, and this is basically associated with cyclones, like in this like a lower Wisla basin that is here. So it means like they will have like a more like the relation between these cyclones and in this part is because they will have like a more precipitation in this region, and for that reason, like the floods are occurring like later. And also like in the Tatra Mountains on the south, like the floods are occurring like earlier. Let's say if before they occurring like today, in this study, say like we will have like 5 or 8 days earlier. It's like a really important to say like the significance of this is like a really small, because like all the different factors that is like interconnected with the flood timing is like a really hard to catch. So for that reason, like the statistical significance is like lower. Yeah, it's like the summary of the principal points that we detected with this work. First of all, is like the use of 2 complementary like approaches, like the peak of the threshold line, like the annual maximum flow, will allows us to have like a better comprehension of the floods trend in Poland. Also, like the comparison of 2 different subsets demonstrate that we have like a higher significance in the shorter period, let's say like in the longer period than the shorter one. Then that we have like a mark, like a spatial pattern in the magnitude. That is like in the northeast, we will have like in general, we face like a less flood magnitude. And also, this is one of the first analysis that of this topic that we didn't have like too many of Poland. And the influence of climate variation should be like really considered into next steps, because we are facing like too many atmospheric conditions that can vary like the behavior of the floods. And like this is like also like a really important to mention, like the results that I show you here not necessarily continuous in the future. It is like due to climate change and other factors. And for that reason, it's like important to make a note and try to have like an attribution of study that what is like the principal drivers of the floods in Poland. For example, if it is like the extreme precipitation, if it is like a snow cover or it is like a soil moisture. So for that reason, it's like a really important. And our like a next step is like to have like a attribution analysis of the floods in Poland. And now it's like just like a briefly examples of this like a study, but I'm going to focus more in the Baltic states. For example, this was like a study of Blach et al. In 2017. And they study like the same, they study like the timing of the trends in over Europe. Here you will have like in blue colors is like a later occurrences in the red colors like earlier occurrences, and in general like in this part of the Baltic states they show like basically. In the past are like associated with earlier flood occurrences, and like in the next flood that is like this in the middle is like a really important because they have like studied like the different drivers of the floods. So in this like for example the green is like the observed floods that they detected. Then like the orange is like the snow melt indicator. The purple is like the maximum precipitation. And you can see with that like the main driver of floods in the Baltic states are associated with the green one that is like the maximum, the green one that is like, the green one is like the floods, but like the orange is like associated with soil moisture, and the soil moisture means like they have like a more temperature, and for that reason we will have like a less snow cover, and for that reason we don't have like a such a floods in this sector. And also this is like another study of Kemner in 2020, and it's basically they study like the principal drivers of the floods around Europe, like for example rain, soil moisture, snow melt, and rain and snow. And you can see like the mainly driver that is like a really important to put like focus on it is like the snow melt in the Balkan states. As you can see, it's like the relevance is almost like a 100 or 80%. And like the other factor that is like really important in the soil moisture. So these two like factors are like the principal drivers of floods in the Baltic states. This is like the map that Maria showed at the beginning, and is like the measure that she said is mostly the same measure that I will say. Because, for example, in this like states, we will have like a different behavior with increases of 1.5 temperature of 3 global warming, and you can see like we will have like in some rivers like a decrease of the discharge. So in these rivers we will have like more droughts, and in other rivers, for example, there are like for example Lithuania, Latvia, and some of them like even in Estonia. So in this part, we will have like in the future more floods. Yeah, that's all, and thank you so much for your time.